All right, Honors Chem, sorry about my computer. We're going to try and get these oxidation numbers assigned really quick. So here we go. We're going to start with water. We already talked about it at the end of the video, the other video when the camera was freezing. So we're going to start with the most electronegative element. So the most electronegative element in water is oxygen. So if we look at our periodic table for oxygen, let's see, let's get that periodic table up. You'll realize that oxygen is right here. It is in the third to last column, so that was a -2. So we will assign that a -2. So when we get to oxygen, we've got a -2. So we know that this whole thing has to add up to 0. The sum of all oxidation numbers must equal 0, or the charge of the polyatomic ion. This has no charge, so it's got to add up to 0. So what plus -2 is going to add up to 0? +2, right? So we got 2 hydrogens right here. So +2 divided by 2 will give us a +1. So that means hydrogen here is a +1, and oxygen is a -2. Okay, so we're going to do hydrogen peroxide in just a minute, really quick. So let's go on to carbon monoxide. Once again, we're going to start with the most electronegative element, and that happens to be oxygen. So oxygen's a -2. So what does the carbon have to be to get it to all add up to 0? So what plus -2 is 0? So hopefully you have the carbon being a +2 and the oxygen being a -2. All right, let's look at carbon dioxide. Once again, we are going to start with the most electronegative element, which is oxygen. And we're going to assign oxygen a -2. We've got 2 of them, so that gives us a grand total of -4. 2 times -2 is -4. So what plus -4 equals 0? What does that carbon have to be? Hopefully you said that that carbon has to be +4. So that carbon's going to be +4 and the oxygen's going to be -2. Okay, let's go back to the hydrogen peroxide. As of here, we've started always with the most electronegative element, so that gives us -2. And we've got 2 oxygens, so that gives us a grand total of -4. So that means the hydrogens all together to add up to 0 would have to be +4. So that would mean +4 divided by 2, because I've got 2 of them, would give hydrogen a +2. Now, let's go back and think about this. We can't do +2 for hydrogen, and I'll tell you why. There's this little rule here. Elements can only be as positive as possible, i.e., they can only lose how many valence electrons they have. How many electrons does hydrogen have? It has 1. So the most hydrogen can have is a +1 charge. That's it. So this is not going to work. Hydrogen can only have a +1 charge. So we're going to have to rethink this. So if hydrogen is a +1 charge, and I've got 2 of them, that gives me an overall charge of +2 for the hydrogens. That means the oxygens all together have to be -2, and I've got 2 oxygens here. So -2 divided by 2 gives the oxygen a -1 charge. Oxygen is not fully filled with those 2 extra electrons in this valence shell to get that noble gas configuration. That's why hydrogen peroxide is so reactive, by the way. Okay, so let's move on. Ooh, we've got the hydrogen, we've got nitric acid here. So once again, we're going to start with the most electronegative element here, which is oxygen. We're going to assign oxygen -2. So -2 times 3 gives us a whole charge of -6 for those oxygens. Okay? So hydrogen is going to be a +1. We know that for sure. So let's see. +1 plus -6 still gives me a -5. So what plus -5 gives me a charge of 0? +5, right? So the nitrogen here has to be a +5. Okay. Now let's look at sodium sulfite. Oxygen, once again, is a -2. -2 times 3 gives me a grand total of -6. Sodium is in that very first column on the periodic table. So it has a charge of +1 right here. So we're going to assign sodium a charge of +1. But we've got 2 of them, so that's going to give me a +2 altogether. So +2 plus -6 will still give me a -4. So what plus -4 equals 0? The sulfur has to be a +4. Okay? All right, I want you guys to do this by yourself. Try this next one. Okay, potassium permanganate. We're going to start once again with oxygen. Oxygen is a -2. I've got 4 of them, so that gives me a grand total of -8. Okay? Potassium is in that first column, so it's going to have a charge of +1. We only have 1 of them, so that's what we're going to do. So let's see, +1 plus -8 will give me a -7. So what plus -7 gives me 0? +7. +7. And you're like, hold up. Does manganese have 7 valence electrons to give up? Let's check it. So manganese, here we go. We've got 1, 2, 3, 4, 5, 6, 7 valence electrons that we can give up. So yeah, manganese can actually have a +7 charge. Okay, here we go. Calcium nitrate. We can think of this 2 ways. We can do it all as one. Sorry, my dog's throwing her ball at me. She wants to play. It's came to. Come here, Kalea. There she is. There's my pups. Okay. So we can think of this as calcium +2 and then nitrate -1. We can break up the ions, or we can do it all in one fell swoop as the whole molecule calcium nitrate. So if we do that, we can think of oxygen being a -2, and we've got 3 times 2, we've got 6 of them. So -2 times 6 will give me a -12. Okay, we know that calcium is in this second column right here. So it's going to have a +2 charge. Okay, so we can know that already. Come on, I want this. So calcium is a +2. Okay, so +2 plus a -12 will give me a -10. Okay, now notice we've got 2 nitrogens. So 10 divided by 2 gives me a +5 to get us to 0 for that nitrogen. So you should have +2 for calcium, +5 for nitrogen, -2 for oxygen. Okay. Next, we have sodium carbonate. So let's see, oxygen once again, -2 times 3 gives me a -6. Sodium's in that first column, so +1. I've got 2 of them. That gives me a +2. So +2 plus -6 is -4. So that means the carbon has to be +4. And yes, the carbon has 4 valence electrons to give up. So if we look at carbon, we've got 1, 2, 3, 4 valence electrons. So that's as high as carbon can be. All right, nitrogen dioxide. We've got -2 for the oxygen. So that gives us a -4. So that means the nitrogen has to be a +4. Okay, how are you doing so far? Now, we've got one with a charge. See that little dash right there? That's a -1. So this whole thing is going to have to add up to -1, not 0, but the charge of that ion. So we're going to start with oxygen once again. Oxygen is a -2, and I've got 4 of them, so that gives me a total charge of -8. Hydrogen's a +1, so +1 plus -8 gives me a -7, and I need to get that to add up to -1. So what plus -7 adds up to -1? Did you have +6 for your sulfur? And does sulfur have 6 valence electrons? It indeed does. So we can do that. All right, here we go. H2S2O7. Once again, we're going to start with oxygen. We've got -2, we've got 7, so that gives us a -4. Hydrogen's going to be a +1 times 2, so that's going to be a +2 altogether. So +2 plus -14 gives me a -12. I have 2 of them, so 12 divided by 2 is a 6. So sulfur has to be a +6. All right, aluminum sulfide. Sulfur is the most electronegative here, and sulfur, once again, is going to be in the -2 column here. So we're going to assign sulfur a -2. I've got 3 of them, so that will give me a -6. So that means the aluminums all together have to be a +6, but I've got 2 of them. So 6 divided by 2 will give me a +3. Okay. And then chlorine is in my -1 column right here. So chlorine will be a -1. And I've got 2 of them, so that will give me a -2. So that means the manganese to add up to 0 is going to have to be a +2 for the manganese. All right, here we go. Here is a covalently bound compound. So this is how we do this. We look at oxygen, or the most electronegative thing first, which is oxygen. I've got that assigned as a -2. I've got 6 of them, so that will give me a -12. Next, we're going to look at hydrogen. So hydrogen is a +1, and I've got 12 of them, so that gives me a +12. So +12 plus -12 is 0. So that means my carbon here is 0. Okay. All right. Manganese oxide. So oxygen, -2. I've got 4 of them, so that will give me a -8. So that means the manganese altogether has to be a +8. And I've got 3 of them. So this is actually going to be a fraction. I'm going to have 8/3. That means that 2 of my manganese are probably going to have 2 +2, and then the other one's going to be a +3. Okay, so remember, this is not true electrons like this. There's only 8/3 electrons missing on these, but it's kind of a bean counting, like this is our best guess of what is going on. Okay, so this is how we assign oxidation numbers. The next video, I'm going to show you how to do oxidation numbers, and we're going to then look at what's oxidized, what's reduced, the oxidizing agent, and the reducing agent. So we'll see you next time. Bye.